All right. So y equals sine of, whoops, y equals sine a sine of b times x minus c plus d. A is amplitude. So that's the stretch or shrink vertically. So A is amplitude. That's stretch or shrink vertically. B is period. That's stretch or shrink horizontally. So amplitude stretches or shrinks it vertically, up and down. Period B stretches or shrinks it horizontally. C is the phase shift. So it translates it right or left. And D is a vertical shift. It translates it up or down. Okay? So this is what you need for graphing sine and cosine. You need to understand A, stretches or shrinks vertically. B, stretches or shrinks horizontally. C, slides it right or left. D, slides it up or down. So you've done A, C, and D in that first section. So today is about B. And tomorrow we'll do some more about B. Okay? So we'll just do a few problems today involving period and a few problems tomorrow involving period because we just have short classes and that's the way it is. Okay, everybody got this? You good? We good? We good? Okay. So y equals sine of 2x. So b equals 2. So normally for sine equals, for y equals sine of x, how long is my period? Well, let's look at that. So let's go pi over 2, pi, 3 pi over 2, 2 pi. And then I'm going to go 5 pi over 2, just to show you what I want you to know. So sine starts at 0, 0, pi over 2, 1, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and so on. I can't believe that just happened. There we go. All right. A period is how long until something repeats itself. So a sinusoidal curve will go forever to the left and forever to the right because of coterminal angles. You can keep going around the unit circle forever. Okay? So we can keep going and going and going, and it just keeps going up and down and up and down and up and down forever. So how long until it starts repeating? How far did we go until we got back to our original point and then we just started repeating? 2 pi. This is one period. From here to here is 1 period. Okay? That's until we started repeating ourselves. Okay? Because this point's the same as this point, and this point's the same as this point, and so on. So we went 2 pi until we repeated ourselves. So when we put a number in front of this x, it'll affect the period. Okay? It'll affect the period. So when I say the sine of 2x, my b is 2. My period will equal 2 pi divided by b. My period will always equal 2 pi divided by b. Well, what's 2 pi divided by 2? 1 pi, right? So what will happen in the sine of 2 pi is the period will happen in 1 pi and everything will start repeating after 1 pi. So if I graph, and let's do this in yet another color. If I graph y equals the sine of 2x, then what's 2 times 0? So the sine of 0 is 0. What's the sine of pi over 2? What's the sine of pi over 2? What's the sine of pi over 2? 1. Thank you very much. The sine of pi over 2 is 1. So if I would say y equals the sine of 2 times pi over 2, that's really the same as the sine of pi. Well, what's the sine of pi? 0. So at pi over 2, I'm going to be at 0 again. That's weird. Well, what about at pi? Y equals the sine of 2 times pi. Well, if I'm at pi, well, what's the sine of 2 pi? 0 again. Boy, it looks like I have a straight line. But let's go in between here now. What's the y equals the sine of 2 times pi over 4? What's 2 times pi over 4? Well, that's 2 pi over 4, which is pi over 2. So at pi over 4, it should be the same as what the normal graph of pi over 2 is. So at pi over 4, I should be at 1. And what do you think I'm at 3 pi over 4? Negative 1. So what happens is if you put a 2 in front, it doesn't get twice as wide. It gets twice as skinny. Okay. I can basically put two periods in the place of 1 period because of that 2 there. Okay, because of that 2. I can put 2 periods where there used to be 1 period. All right, so let's start with a new one. Y equals cosine of 3x plus 1. The cosine of 3x plus 1. So what I'm going to graph out here is I'm going to graph y equals the cosine of x, y equals the cosine of 3x, and then I'm going to move everything up 1. Now, the 3 is in front of x. Here's where you have to be careful. Since this is a 3, my period will be 2 pi divided by 3. What's my denominator? 3. So you have to make pi a multiple of 3. like 3 or 6 or 12. I want to make it 9. 12. So I'm going to make pi 12 here just to have fun with it. So I'm going to make pi 12 long because 3 is divisible by 12. If I made pi 8 long, does 8 and 3 go into each other? No, and then we have a mess. So I made pi 12 long, which makes pi over 2, 6 long. And the reason why I spread it out is because this is going to become not 3 times wider, but 3 times skinnier. So I want to stretch out my graph a little bit so I can see my graph a little easier. All right, so I go another 6 to get to 3 pi over 2. And another 3, 6 to get to 2 pi. All right, so now I have my graph laid out. I am going to graph my original y equals cosine of x in this plum color. So it starts at 1, goes to 0, goes to -1, goes to 0, goes to 1. Now, if I had a 3 in front of cosine, it'd make it 3 times higher and 3 times lower. But there's just a 1 there. The 3 is in front of x, which affects the period. So everything's going to be 3 times skinnier. Okay, 3 times skinnier. So since it's 3 times skinnier, I'm taking 1/3 of the distance from the origin to the point. So if I graph in blue y equals the cosine of 3x, 3 times skinnier, instead of going over 6, how far am I going to go over? What's 1/3 of 6? 2. Instead of going over 12 to get to pi, I'm going to go over 1/3 of 12 is 4. Instead of going over 18, 1/3 of 18 is 6. So where 3 pi over 2, I'm going to be at 6. And then the last one is right there. So it's going to look like that. What do you think this point is right here? What do you think that point is? 1/3 of the way. Oh, I screwed up, didn't I? I went too far by 1. Went too far by 1. This point right here. So, if I go 12 spaces to get to pi, pi over 6 would be 1/6 of that, or 2 spaces. Pi over 3 would be 1/3 of that, or 4 spaces. So if I go 4 spaces to get to pi over 3, I go 8 spaces to get to 2 pi over 3. See how my period is 2 pi over 3? Okay. Then, in my last graph, I have to raise everything up by 1. Up by 1, up by 1, up by 1, up by 1, up by 1. And there we go. Okay, that's what your graph should look like. Y equals 3 cosine of x plus 1. All right. Now, to hopefully not confuse you too much, but let's go y equals 2 sine of 1/2 x. Y equals 2 sine of 1/2 x. Now, let's not write these up. Yeah. So, what's 1/2 in front of x going to do? If the 2 in front of x made everything twice as skinny, what's the 1/2 going to do? Make it twice as wide. Because your period is going to equal 2 pi divided by 1/2. those Algebra 2 people know that this is a complex fraction. What do you do with, how do you get rid of a complex fraction? Multiply by the reciprocal of the denominator, or multiply by the denominator, whatever. So these cancel, and period equals 4 pi. So if I go 4 spaces to get to pi over 2, 8 spaces to get to pi, I'll see if I have a room. 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. Okay? So it's going to be that wide. 1, 2, -1, -2. So what I'm going to graph first is y equals sine of x, 0, pi over 2, pi, 3 pi over 2, 2 pi. Graph the normal sine curve. Then I'm going to graph y equals 2 sine of x. What does that 2 in front do? Nope, 2 in front. That's A, stands for amplitude. Twice as high, twice as low. And then the green one here, the 1/2, puts everything twice as far away. So we still start here. Instead of going pi over 2, I'm going to go to pi. And that high. Instead of going to pi, I'm going to go 2 pi. Instead of going 3 pi over 2, I'm going to go 3 pi. And then to 4 pi. It's going to look like that. Okay? We good with that? All right. You know what? Let's do one more, and then I will give you an assignment. Y equals 3 minus cosine of x over 5. Ew. What's that 3 in front do to it? Three up. What do you mean by 3 up? Absolutely. That's exactly what we want to do, Remington. Absolutely. This is written kind of in the wrong order. Okay? They'll throw this at you, but it's written in the wrong order. What this really means is y equals -1 cosine of 1/5 x plus 3. That's what it means. Even though it's written like this, it really means that. 1/5, what's that going to do? Stretch it out how many times? 5. It's going to really stretch it out. So you got to be very careful how you label everything. Okay? So I'm only going to go 2 to get to pi over 2 and 4 to get to pi. 6 to get to 3 pi over 2. And then 8 to get to pi, or 2 pi. Then I'm only going to label my pi's after that. So 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. How far do I have to go? 8 pi. Anybody going to stop me? 9 pi, 10 pi. Stop there? That's right. Because normally my period is 2 pi. 2 pi divided by 1/5 is 10 pi. Okay? And then I'm going to go up by 3. So I'm going to go 1, 2, 3, 4 here. Because I know I'll go at least that high probably. -1, -2. Okay. So graphing this. The first thing I'm going to graph is y equals cosine of x. The normal cosine curve. Where does the normal cosine curve start? 1. So it's 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1. And then negative cosine. What does that do to that graph? Reflects it over the x-axis. So it starts at -1, pi over 2, 0, pi 1, 3 pi over 2, 0, 2 pi, -1. And then I'm going to do the 1/5. Purple. Y equals negative cosine of 1/5 x. So everything's 5 times wider. So 0 times 5 is still 0. I start in the same place. Pi over 2 is at 2 spaces over. So I'm going to go 10 spaces over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm right here. So 20 spaces over. 1, 2, 3, 4, 5, 6, 7, 8, 9. To get to here. This was 4 over, so now I go 20 spaces. And then 30 spaces, which is right here at 7.5 pi. And then right here at 10 pi to get where 2 pi was. So it's a really stretched out graph. And then we're just going to go up by 3. So 1, 2, 3 up. 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 Ta-da. We good? Okay, that's what we're going to do for tomorrow's assignment. So 4 problems again. Okay, 4 problems again. I will check your 2.1s tomorrow. So we are doing 9 through 15, the odds, page 127. There you go. Yep.